So, welcome to our next lecture. This time we're going to talk about the experiment tracking with weights and biases. When we look at our course, we are in this stage, fine-tuning. And as I mentioned previously, experiment tracking is a very important part of the pipeline, not only during the experimentation stage when data scientists develop its model, but also during the production stage where we monitor the model, for example, for the model drift, which is going to be a next topic of our lecture. So, as previously in the codes and examples you will find in my folder, we will use the example of high revenue prediction of the customers of the e-commerce store which sells online t-shirts. So this is the same example we used in Kedro pipelines. We are going to use weights and biases. As I mentioned in one of my first lectures, the first lecture precisely, there are plenty of tools for machine learning experiment monitoring. You'll find MLflow, extremely good open source library developed by Databricks and obviously the public community in the internet. You have Neptune AI, which is also great, and plenty of other very good solutions. I choose weights and biases because it's very useful, very interesting, very easy to use. It has two pitfalls for you as someone who may be used to use open source solutions. First, it's not open source, yes, so this is the disadvantage. And the second, it's cloud-based, so whenever you wanna use your private data, sensitive data, you probably won't be allowed to do this. Obviously, they have some solutions for that for companies, otherwise nobody would use it, but still, these are the two pitfalls. But still, since it's good to know sometimes also the benefits of the commercial platforms, I strongly recommend you to use it in our project specifically because you won't probably have to pay for this. The free tier is really, really handy. And so let's talk about the basic features. These are the features of almost all experiment monitoring tools, so they are not specific to weights and biases itself, so do not treat this demo as a demo of weights and biases. It's rather used to illustrate the capabilities of solutions in that category. So we are going to talk about some basic logging next, how to log plots and tables generating during our process, during our run, log and use artifacts and tune hyperparameters because that's also possible in weights and biases. So firstly, this is the very basic use. So you can automatically log basic parameters and measures across multiple runs. So that may be measures of the quality of your model. As you can see, we have only the single point since during a given run we had only a single run. So we had only one training of a single model, so that's why there is no plot here. But moreover, during such a single run, we may track automatically system logs like network traffic, disk utilization, process CPU threads in use, memory utilization, etc. By the way, that may also be very useful for you in your experiments. We would like to identify the impact of different hardware configuration on your training efficiency. So it works roughly, you'll see this in examples, the way that you inject a small snippet of the code into your Python script, and it will do the logging for you. So if you run the same code on different machines, like your notebook, your server, your cloud server, whatever you use, then you can compare the efficiency of your run on different machines. That's for choosing the optimal hardware setup for you. So you may compare quite easily different runs, because run is just a single run of the machine, but you may run it many times using different hyperparameters or in different machines. So you can choose different parameters to within a so-called experiment, different parameters to compare. You can sort those tables, but you can also log plots automatically. So, for example, weights and biases has a very good integrations with the most popular data science libraries like scikit-learn or PyTorch. So with a single command, you can ask it to log the plot for you. What does it mean? What does it mean integration? Obviously, you can do it manually. So you can generate the plot within your Python script, save it to the file, and log this plot as the artifact. Nope, here it's a bit smarter, much smarter in fact, because it allows you to generate the plot automatically from the code without saving it as a graphic file onto the drive, and such an automatically generated plot will be sent to the weights and biases to be reported in the report. But you can also log tables if you in your snippet specify that you would like to log a given pandas data frame. It will do it for you, and then this is the print screen of one of the example reports. You can export this as a summary, so that's sometimes a very important artifact, so you can use weights and biases to sort it. So you can log plots, parameters, plots, tables, and different artifacts like datasets or models. This is also a very interesting idea. So you may use weights and biases as a data versioning tool, data version control tool. Once again, this is not the specifics only of weights and biases. Other solutions like MLflow also allows for that. So it's not tool specific, but generally I'm just simply illustrating using weights and biases to illustrate the most common capabilities. Moreover, you can track artifacts lineage, how they are transferred during the pipeline, and reuse them if needed. So this is the example snippet where I can create in my Python script a new data frame which will use the run object. This is the object generated by weights and biases. So this is taken from the weights and biases library, and then I have a method use artifact, and then I specify the name of this artifact from my hosted solution, yes, from my account, my project in weights and biases, and it will download it and either read this to be reused in the code, or then I can download it to my drive. So such a data versioning might be useful, for example, if you move your solution from one machine to the other and you would like to reuse some artifacts from previous runs but on the other machine. You can also, this is a very handy feature, automatically tag the best model as best. So imagine that you have plenty of runs in a given experiment and it run, for example, in a loop. And within such a loop, you encounter one of the models to be the best because you are looking for the best model in terms of some quality measure, which is important to you. Then such a model will be automatically tagged as best. So for example, if this run is the run number 54, and this is the best tag, and the next run 55 is worse, so the tag is still kept with the model number 54 as the best one, but in the, for example, run number 60, if the model in that run is better than that one, which was the best actually from the run 54, the tag will be passed to the model from the run 60. So it's automatically tagged as best. And then you can track its lineage of this artifact, as you can see here, and then reuse it in your CI/CD pipeline. So this is very handy also for me, because, for example, imagine that you retrain your model on a daily basis using some automatic tools, and then after this retrain you would like to automatically take the best model to your production and deploy it to serve later on to your customers. Then you can automatically use this line, which looks like that, to pull the best model from all the trains which are made during the night, for example. So we can use it automatically in your continuous integration, continuous deployment pipeline. So another very interesting feature is intelligent hyperparameter sweeping. What does it mean sweeping? Imagine that you have some model, for example, as here for binary classification, you may have different machine learning algorithms to try. Each algorithm has different set of hyperparameters, and your goal is to identify that set of parameters which maximize your quality measure, like for example here, receiver operating curve area under the curve. So this is a very typical optimization problem. You are going to find the best set of hyperparameters. You might have, for example, 5 different hyperparameters in your model. So how to do this? You can do it obviously by hand. For example, it's so-called, the easiest method is so-called grid search, when you just simply having, for example, 2 parameters to sweep, you choose some regime of that for the parameter 1, another regime for parameter 2, and you scan it, for example, for 5 different values for parameter A, 10 different values for parameter B. You have 50 different trials, 50 different runs to compare, and this is so-called grid search. It's not smart, it's automatic, but you may use some smart methods like Bayesian based. So for that case, you'll probably use Optuna as a very, very smart library for intelligent hyperparameter optimization, or you can use Weights and Biases, who has the libraries like Optuna already implemented. They integrate with that, and for that case, you can ask Weights and Biases to run different experiments for you, and it won't use the grid search. If you can see here on this plot, it looks very strange, but it shows us only 2 parameters which were scanned. This is our measure. So how to read this parameter, how to read this curve? Look, for that value of the parameter 1, which is max depth, probably of some decision trees, and then this number of estimators, so that's probably random for us, I guess, we get that value, bad. This is a bit better. So as you can see, this is max depth 10 and 190 something for number of estimators. It's much better. But look what happens here. Those combinations like 20 estimators and max depth 10 results with the highest value of your target quality measure. But how does it cope with my previous statement about the grid search? Look at those trials and errors. It's not a grid search. If it was the grid search, we would have tried 3, 3.5, 4, 4.5, 5, etc. No, look, it chooses like randomly, or the values here are they look like randomly, but they are simply controlled by some intelligent algorithm which learns from each trial and error. So this is first very interesting feature in the hyperparameters swapping, but there is also another one. This is displayed here. So this is extremely important part of the methodology I would like you to follow. This is always the question, why do we make experiments in machine learning, for example, in general? You may say, okay, we do experiments in order to make to find the optimal set of hyperparameters to make our model better than the previous one. Here I advise you another strategy, a more egoistic strategy. I suggest to approach the experiments as a way of improving your knowledge and understanding of machine learning. So instead of putting the model quality first, put your understanding first. Why? Because if you get wiser and wiser from experiment to experiment, in your next runs or in your next projects, you will faster achieve your goals. And that part of the screen is devoted precisely for that. Look what happens here. After many runs, I can see that max depth is much more important for this tuning of the hyperparameters than the number of estimators. So this is the lessons learned for you. So for example, for your next project, you rather play with max depth parameter, not number of estimators, yes, because it's computed statistically from different runs, the parameter importance with respect to ROC. So if your ROC, receiver operating curve area under the curve, is a key measure for you, you may note down in your notebook that for that type of the problem, for that algorithm, and for that measure, you should in the future focus rather on max depth than on estimators. Seems trivial, but if you have hundreds of such parameters, that become really important for the future experiments. Obviously, nowadays we have a lot of AutoML solutions which do the job for you, but still learning that stuff, especially in the context of large language models and generative AI, is crucial. So, but coming back, tools like weights and biases or other tools may also not only automate the experiments for you, but also help you learn and understand the AI better. So that's all for that. I strongly encourage you to look at different tutorials on weights and biases, to follow my tutorials, my examples, and next apply those tools in your project. So happy coding. Thank you.